Okay, so this recording is the first page of the review. So it says, which describes the end behavior of the following. So when I look at the function, whoops, let me go ahead and hit the pen. Okay, when I look at this function, I always want to look at the highest degree. The highest degree is 3, and the leading coefficient is -3. So that's a negative odd power, negative odd function. So I know that the end behavior is going to look something like this. So as x approaches positive infinity, y goes to negative infinity. As x approaches negative infinity, y goes to positive infinity. So my correct answer is D. Number 2, what is the greatest number of real zeros of the function? When we look at the number of real zeros, we look at the highest exponent. Okay, my highest exponent is 3, so that means that the greatest possible number of real zeros is also 3. Question number 3. What is the greatest possible number of turning points? When we think about turning points, it is n minus 1. It's always going to be 1 less than the highest exponent. So the degree of my polynomial is 5. So 5 minus 1, is 4. So the greatest possible number of turning points is 4. All right, let me scroll down a little bit. Nope. Come on. All right. So next question, divide using synthetic division. So when I have synthetic division, it gives us a factor. I'm going to set that factor equal to 0. When I set that factor equal to 0, I get x equals 2. So that is what I am dividing by. Now remember, when we're doing synthetic division, we have to have every single power taken into account. So the highest degree here is 4. So I have 6, and I have -12 for my x cubed. And then don't forget about your x squared. You don't have an x squared term, so that means we have to put a placeholder of 0 right there. Then next I have 9. Then I have -12. Just to double check, -12, 9, 0, -12, 6. Perfect. Okay, synthetic division. We bring down this first term, this first value. Then we're going to multiply. 2 times 6 is 12. Then we add. -12 plus 12 is 0. Then we multiply. 2 times 0 is 0. Then we add. 0 plus 0 is 0. Then we multiply. 2 times 0 is 9. No, 2 times 0 is 0. And then we add. 9 plus 0 is 9. Then we multiply. 2 times 9 is 18. Then we add, and we get 6. 6 right there, that is my remainder. So now we need to write our polynomial. So this is my constant term. 9 is my constant term. Then I have my x term, x squared term, and x cubed term. So the polynomial that I have left is 6x cubed plus 9 plus 6, the remainder, over our divisor. We are dividing by x minus 2. So that would be D. Okay, number 5. Find the remainder when 2x cubed plus x squared plus 3x plus 7 is divided by x plus 2. Is the binomial a factor of the following polynomial? So first let's go ahead and divide it. So again, it gives us a factor. We set our factor equal to 0, and we get -2. So that is the value in which we are going to be dividing by, setting up synthetic division. You could also use long division, but synthetic division is a little bit faster, so that's what I'm choosing to use. So we're going to set this up. We have 2, 1, 3, and 7. Every power is taken into account, so I don't need to put any placeholders. So I'm going to bring down the 2. I'm going to multiply -2 times 2, which is 4. Then I'm going to add, which is 5. I'm going to multiply -2 times 5, which is -10. Then I'm going to add, and I get negative 7. And I'm going to multiply. Negative 2 times negative 7, which is 14. Then I add, which is 21. So 21 is my remainder, unless I did something wrong. Which I did. Okay, sorry about that. I made a small mistake right here with this 4. So let me go ahead and set it up again. So I have negative 2, 2, 1, 3, 7. All right, bring down the 2. Negative 2 times 2 is negative 4. 1 plus negative 4 is negative 3. That's where I messed up on the last one. Negative 2 times negative 3 is positive 6. We have 9. Negative 2 times 9 is negative 18. Then when I add, I get negative 11. So negative 11 is my remainder. So that leaves me between either D or B. So if something is a factor of the polynomial, then it's going to have a remainder of 0. So the remainder was not 0, so no, it is not a factor. So that means that B is the correct answer. All right, number 6, which is not a possible rational zero of the following polynomial. So when we think about possible zeros, we always look and take all the factors. So plus or minus the factors of the constant term over the factors of the leading coefficient. So that would be P over Q. This is my P. This is my Q. So you get plus or minus 3 and 1. That's my factors of 3. And 2 and 1, which are my factors of 2. Now when we look at possible, I'm going to continue right here. So I have 3. So when you do this, you have to divide. You have to find all the possible options. We have 3 over 2. We have 3 over 1. We have 1 over 2. And we have 1 over 1. So 1/2 is a possible 0. 3 is a possible 0. 3/2 is a possible 0. 2/3 is not. So 2/3 is my answer. All right, last question on the first page. Find the polynomial function of least degree with real coefficients in standard form that has the zeros of negative 1, 3, and plus or minus 3i. So remember, whenever we do imaginary numbers, they always have to come in pairs. We want to have the plus and we want to have the minus. And think about why that is. I'll show you in a second why that is. So when I set this up in factored form, remember standard form means that we need to multiply it out. So in factored form, I would have x plus 1, x minus 3, and x minus 3i, and x plus 3i. So here are my conjugates, negative 3i and positive 3i. The reason we do that is because that middle term is going to cancel out when we multiply them together. So let me first go ahead and multiply x plus 1 times x minus 3. When I multiply those together, I will get x squared minus 2x minus 3. Now I'm going to multiply together my imaginary factors. So I'm going to distribute x times x is x squared, x times negative 3x, x times x is x squared, x times 3i is a positive 3xi. Then negative 3i times x is a negative 3xi. Then negative 3i times positive 3i is negative 9i squared. So don't forget, what does I squared equal? I squared equals negative 1. So right here, that right there is going to equal negative 1. So I'm going to bring down my first factor, x squared minus 2x minus 3. And now, if you notice right here, we have the positive 3xi and the negative 3xi. That is 0. So now we no longer have imaginary numbers. So I have x squared. Now negative 9 times negative 1 is positive 9. So I have x squared minus 9. Now we need to multiply out the rest, and then we have our final answer. So I'm going to take my x squared, and I'm going to distribute it to everything in my first polynomial. So what I have is x to the 4th minus 2x cubed minus 3x squared. Then I'm going to take 9, and I'm going to multiply 9 times everything in my first polynomial. So plus 9x squared minus 18x minus 27. I'm going to combine like terms, and that is going to be my final answer. So I have no other x to the 4th term. And I don't have any other x cubed terms. And now I have 2 x squared terms. That's going to be positive 6x squared, negative 18x, negative 27. Let's look at our option choices, and that would be